Let us discuss a question from fluid mechanics. So we have a water level of 20 meters height in a tank where the top pressure is 2 atmosphere gauge. Remember, it's a gauge pressure, so uh, it's not absolute. Okay, and then you have a pipe. At the end, you have a nozzle where, because the water that will be coming out from the nozzle will be at a very high speed, and so when you keep the top end like this, so obviously it will the velocity will not end immediately. Somewhere at the top the water level, it will rise up to a certain height, so at that point the velocity will be zero. So that is the question, the velocity will be zero here. So as it is a question relating pressure and velocity, so I will first determine two levels. This is reference point 1 and this is reference point 2, at which the water level, the max height up to which the water level rises. So these two levels, and datum is my this. Okay, so I apply a Bernoulli equation where I write P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. So now P1 is the gauge pressure plus P atmosphere. Now the gauge pressure is 2 atmosphere and atmosphere is 1 atmosphere, so 3 atmosphere. Whereas P2 uh, is the pressure at this point at 2, which is P atmosphere, which is 1 atmosphere. Now coming to velocity V1 is 0 because of the large area of cross section. So the decrease, the rate at which the water level decrease here happens is very small, which is 0. V2 is the velocity at this level, at this reference point, that is 0, because otherwise, I mean, if it is not 0, the water would still rise upward, but this is the maximum where it can go, so that is 0. So we both V1 and V2 are 0. That is an interesting thing that is happening in this problem. Z1 is the height of the reference level, level 1 from the datum. So from the datum it is 20, and Z2 is the height of the level 2 from datum, which is h. So that is the thing. So now once I get all the parameters, I substitute it here. Now remember that at 1 atmosphere we have to convert everything into Pascal. So 1 atmosphere is 1.013 into 10 power 5 Pascal. So this is something which you got to remember while substituting this. So P1 is 3 atmosphere, so 3 into 1.013 into 10 power 5 Pascals. The density is 10 power 3 and G is 9.81. Okay, plus velocity is 0, Z1 is 20 meters, and P2 is 1 into 10 power 5. Okay, and there has to be 1.013 into 10 power 5, so I've just written 1.03 aside, in 10 power 3 into 9.81, plus V2 is 0 and Z2 is something which we got to find out. So Z2 is height. Okay, so everything we know except h, and from this h will come out to be in meters 40.65. okay, so that is approximately 40.7 meters. So by using this is a straight Bernoulli's theorem application problem. So the height up to which the water rises is 40.7. Thank you.